So far we have seen slotted aloha and pure aloha, right? The problem with these two algorithms or protocols were they were not sensing the channel before sending the data. So because of that, so there will be lot of collisions. We have a better model, that is, CSMA, carrier sense multiple access. In that, every station is going to sense the channel before sending the data. If this channel is already free, that means no one is using, then the system can sense it and it is going to send the signals. So what is the advantage of this? I will tell you. Example, let's say this is your pure aloha protocol. Okay, in pure aloha any system is going to simply send the data. This is channel, this is the system. Okay, now this system directly sends the data whenever it has, then there is a high chance that that is going to have corruption, otherwise collision. But in our CSMA we are going to sense it first. If that is free, then only we are sending the data, then collisions will be automatically reduced. It is very intuitive, right? Now because of that, definitely efficiency of the medium will be, otherwise model will be improved. We will see that how this carrier sense multiple access model works. Let's take 4 stations and generally they will be connected like this. This is the common medium, and usually let's take one example medium, that is copper cable. Let's say, so in this copper cable, initially when there is no signal propagating, signal is nothing but whenever it propagates it will have some energy, right? So that stations can sense it. Example, let's say this station is designed such a way that when some signal is propagating like this, then when this system sends it, then automatically it will say that there is a different energy, so there is a signal. If there is no signal, then this cable will not have any energy, then that also it can sense. So let's say we can imagine our that energy levels like this. 0 means, let's say whenever this cable has 0 energy level means no signal. Maybe if there is a signal means we'll imagine like 5 level energy. If there are multiple signals are coming, okay, then the energy will be more in that way. So 0 empty cable, that means no signal. 5 some signal is coming, some maybe someone is sending the data. 10 means already multiple people sending the data, already there is a collision. So when energy level, by seeing the number we can say that whether there is a collision, otherwise there is a proper data, otherwise third one, whether your line is empty or not. So all these things can be sensed. Finally every system is going to sense it. Okay, now one question students generally ask, sir, in this model, so we can say that we'll get 100% efficiency. Then I ask why? No collision. Who said there is no collision? Here also there is a collision. We will see why collision occurs. Before that we will see the operation, how these systems are going to send the data. Example, whenever station A wants to send the data, so it will have adapter. That adapter will sense the channel. Okay, now this channel, let's say free. Whenever that channel is free, then immediately, so that adapter informs your computer, I can say, otherwise adapter is already doing that sending operation also. That means that adapter is responsible to send the data also. Okay, then that adapter is going to send the data, which is nothing but your frame. So your frame will be started going. Now see, imagine this situation. Let's say your medium is currently free. Now station A senses it and it thinks that it is free. At the same time B also senses it. Let's say time 9 o'clock now. Then at 9 o'clock both systems will realize that, so there is no signal on the cable. Then they will immediately start sending. One thing, first of all let's focus on A. Example, let's say only station A has data, then what is going to happen I will tell you. Whenever station A sends the data, that means it will send the signal, then that signal starts propagating. That is a property of the signal. On the copper cable, whenever you send the signal, it will start propagating bidirectional. That means it will go this side and this side. Same signal will go this side and this side. Understand? Remember it. Easily you can understand that if you perceive from C, that means example C is sending the data. So example, that data is 0. Then that 0 is a signal, it will go like this, and at the same time that 0 will go to this side also. Understand? If you send 0 1 0 1, all that signals, every signal will go like this. Okay, so 0 1 0 1 is nothing but the signal, it will go like this. All that signals go to this direction also. That you should understand. Now once that signal hits here, so it will be taken back by this medium. So when this signal comes this side, then automatically that will be taken away from the medium. In that way you can understand. Now, before that signal reaches the end, the right people, that means example that signal is for A, then A can take it. Understand? Now, remember one thing. So, we are going to talk about in this protocol only sensing. That means how a station is going to sense before sending the channel. That is what this protocol says. But how C can send the data to A, how B can send data to D, that is another protocol, right? So we will see that later. Here this protocol only talks about when systems are connected in a with common medium, then how this a station can sense the channel. Okay, we will focus on that. Now every station, whenever they have data, they will sense the channel. So there will be hardware for that. So using that, it will sense the channel. Generally, so when there is a line, this is let's say copper cable. If it is empty, that means there is no signal on it, then energy level will be 0. Somehow that hardware can understand what is the energy level in the cable. Is it 0? Or example, let's say some signal is going like that, because since this all these adapters knows what kind of signals are generated by other computers, so then only these protocols will work. Then let's say that energy level is 5. Okay, then by whenever this adapter understand that there is energy level 5 in the cable, it understands that some data is going. In that way, it can differentiate whether it is 0 energy level signal, otherwise 5 energy level. If 0 energy level signal means what? There is no signal in the cable. 5 energy level means, so maybe there is a signal. In that way, so every station can understand whether the cable is busy, otherwise free. Assume that let's say 9 o'clock, station C understands that this entire cable is free. Okay, now if it sends at 9 o'clock, now 9 o'clock 1 second, at that time station A got data and even it wants to send the data. So remember one thing, so this is going to this direction also. Okay, now station A is also sensing the channel. Now it also gets 0 level energy. The reason is, since signal is at this moment here, right, this signal cannot improve the, otherwise increase the energy level of this cable here. That means when signal is coming from here, from distant place, sometimes your adapter may not be able to find the energy, right energy in the signal. So still your adapter A thinks that this line is free. Okay, so whenever the signal comes to this point, then maybe your adapter can guess it. Understand? So that's why now there is a danger that what if at this moment 9 o'clock 1 second station A sends this channel, then it will see 0 level and that station also sends the data. Now see, at 9:1 the signal starts like this. Now it is going like this. Now it is coming like this. So all these signals will be garbled, right? So now automatically the energy level in this channel will be increased. Now B senses at that moment, then it will see energy level 10. Now it can understand that there is a dash collision. In that way, so stations can detect the collision, of course, but that is not our goal. In CSMA protocol only we are talking about, that means this protocol is only designed to sense the channel. That means this protocol only talks about how to find out whether your cable is free, otherwise busy. That's it. Okay, so collision detection is not part of CSMA. Okay, we will see that in CSMA CD. Such protocol is called carrier sense multiple access collision detection. So now we are talking about a only subset, CSMA. Okay, now finally you understand that how your stations are going to find out whether this cable is free or busy. Now we will see one more thing. Before that, let's summarize whatever we learned. What we have learned is, though we have carrier sense methodology, otherwise technique, still there is a chance of getting the collisions, correct? Because when multiple stations senses a channel, at that time still they might see only some part of the cable, correct? They can only sense some part of the cable. Some part of the cable may be free, but it doesn't mean that it is completely free. Second thing, though your entire cable is free, when all the example, two stations, when they sensed, then that cable may be empty or free, but simultaneously they might send. Simultaneously if they send, then what happens? Then they will collide, correct? That's why we should definitely take care of collision detection. At this moment finally, so how to sense the channel you understand, right? This is about CSMA, that's it. Okay. Now let me add collision detection. So you know what is CSMA, right? So CSMA is nothing but capability of every station sensing the channel. We know that. Okay. Now we will see how collision can be detected. For that we are going to have extra hardware. That hardware is going to detect the collision. For that, what are the things we have to do? We will see. Example, let's say you have hardware, so that can understand the energy level of the cable. That means, so already I told you that, so your energy level of the cable is 0 when it is free. Now whenever the energy level is something number 5, just for our imagination, so that real terminology might be different. Okay, so energy level of, let's say this cable is 5 means some signal is going on. Now when there is a corruption, otherwise collision, what happens? Then multiple signals will collide like this, right? Then the energy, each signal will carry some energy. So maybe when multiple signals travel together, then if any channel senses it, any station senses it, then it will see double, otherwise some more energy in the cable. By seeing the more energy than actual energy of the signal, we can detect that there is a collision. Okay. Now using this energy level concept, your systems can detect the collision also. That procedure is called collision detection. For that you need extra hardware, that's it. Now whenever you detect the collision, what you are going to do, and one more thing, sometimes you should be very careful, because only I taught you now hardware, right? So how hardware works? Hardware, let's say, assume that, let's say there is one more, just this symbol, this is nothing but only to say that we are just detecting the collision. So what we do is, we always, whenever we have data, then we send the data. While sending the data, also we sense the channel. Okay. Now, so the CD is nothing but simply extra capability. Let's talk about collision detection. So far we have seen protocol for carrier sense, correct? How to sense the channel. Now we'll see how collision detection can be implemented. Okay, it is just little bit more, that's it. Now in collision detection, what we do is, we will have same circuit like what we had for carrier sense, remember it. Now what we are going to do is to understand that, first of all we will see a concept called here vulnerable time. So here vulnerable time is nothing but, example, one station started sending the signals, then what is the duration of time on which if another station sends the data, there is a guarantee of collision. Okay, so just think about it. What is the vulnerable time in this one? So if you see the vulnerable time, so here we have to consider propagation delays also. If you remember in vulnerable times in pure aloha and slotted aloha, where we just ignore the propagation delays, because we do not know the propagation delays, and we assume that, let's say, propagation delays were negligible in that model. Don't worry too much about that, collision, pure aloha and slotted aloha, where we ignored propagation delays, because at that time in that model, whatever we were talking, so propagation delays were very negligible. But here now we are considering propagation delays also. Okay, now with respect to that, we are going to define vulnerable time. What is vulnerable time? We will see. Now we have a clear model for medium, right? In pure aloha and slotted aloha, just I told you that there is a medium, and especially the medium was air. Okay, now on that air, so we were only talking about transmission time. So when that slotted aloha and pure aloha, when they have defined at that time, so transmission times were very large if you compare with propagation delay. That's why, so the propagation delay component was negligible, right? But here now we have to consider propagation delay also. Now we will see what is vulnerable time with respect to that too, transmission time and propagation delay. Try to understand what is vulnerable time. Automatically you get why propagation delay is important here. So what is vulnerable time? Example, let's say station A started sending the data. Okay, now after that, what is the duration of time, remaining duration, where no station should send the data? Example, let's say A started sending the data. Immediately if B sends, there is a collision. Now see, this signal is going like this. Assuming that, let's say this system A is leftmost system, that means it is just starting of the medium. Okay, it is at starting of the medium. Now see, now no one should send, so signal is going, just observe the signal. So by that time this signal hits here. Up to this duration, no one should transmit. What happens, we'll see if they transmit before that. So this entire thing is called propagation delay, correct? So whenever signal starts at leftmost area of the medium and whenever it reaches the rightmost area of the medium, that duration is called, or the delay is propagation delay. We know that, correct? So in this one, propagation delay is nothing but the distance between, otherwise the time taken for the signal from the leftmost area of the medium to rightmost, otherwise maximum propagation delay. Now, so example A is sending some signal, the first bit. Let's only focus on the first bit. Remaining bits are coming after that. Let's say first bit is going like this, 0, 0. It's coming like that. Okay. Now, question number 1. When this 0 is going to hit this end of the medium, that is important. Once it hits, it will go off. Okay. That means this 0 is going to stay in the channel for propagation delay of time. So before that propagation delay, example propagation delay, let's take as 10 seconds. Now when station A keeps the first signal or 0 onto the line at 0 time, then within 10 seconds of time it is going to come to the end and it will disappear. Before that it will be on the line. Example, at 8th second what can happen? This 0 you can spot here. That means slowly this 0 is going to propagate. See, at 0 here, at 1, at 2. That means the signal is now here, 0. Now at 3 your signal might be here, at 4, at 5, in that way. At 8th second it is coming here. Now almost it is going to end, but before that D senses the channel and it feels that energy level is 0, that means channel is idle, otherwise free, then it will start sending its first bit at 9th second. Imagine that situation. Otherwise, see the situation. In the worst case, what can happen? At 9th second, you know almost your 0 is going to cross this D, but so far 0 has not crossed D. By that time, now see, D is sending the signal at this moment. Why, sir? Why suddenly it is sending? Because D got the data just now. That's fine. Now D senses it. Still your channel may, your D senses like it is free, because this voltage signal, whatever, this 0 is now having whatever the energy, that energy might not influence this bit, this point. Okay, in that way. So still D thinks that the energy level is 0. Now immediately it will start sending. Now they will collide. Understand? Now what I want to say is, whenever a station starts sending the signal, what is the maximum amount of time, or what is the minimum amount of time others should not send? Sorry, it is minimum, not maximum. At least 10 seconds no one should send. Understand? So that's why I can say that vulnerable time is propagation delay. After that, sir, after that also there is a collision, right? No. Why? I will tell you. Example, let's say A is a station which is at leftmost end, started sending a signal. Okay, I am only focusing on first signal. That first signal is going like this. So its duration is 10 seconds on the medium. At 10th second, it is going to come to exactly Dth position. Okay, just for good imagination. Now D is going to, if after 10 seconds 0 will come to this point, now D can sense the channel busy. But at 9th second D cannot sense it. That means the bit which is sent by channel A, sorry, system A, can be sensed only, it cannot be sensed before 10 seconds. After 10 seconds what happens? 0 will be coming to this end. Sir, we have a question. What is that? Sir, you said 0 is coming like this, right? What if after 0 passes away from D, then here again if D senses now, second bit will come, right? Then after that, second bit, third bit, fourth bit, fifth bit, everything is on the pipeline. So D will definitely see the signal as, your cable as busy, no problem. But the only problem arises when first bit is here. Okay, second bit is here, 1, 1, see this situation. This is a worst case scenario. Now, see the snapshot so that you can understand everything. At this moment, if B senses the channel, it will say that it is busy. C also feels that channel is busy. But D says that channel is empty, free. Why? Because up to now signal did not come to its place. Then only it can sense it. That's why. Now once 0 comes here, D also senses the channel as busy. After that 0 goes like this, then this one will come, this one. In that way, so signals will completely occupy the channel. Now everyone will see the signal as channel as busy, correct? So finally what I want to say is, when A started sending the signal, what is the duration of time still people think that it is empty or channel is still free? Exactly 10 seconds or propagation delay. After propagation delay, everyone will understand that there is a signal on the channel. That is what I want to say. This is a worst case scenario. Example, let's say C is sending, which is in between. That means C is C is a computer which is in between the medium. It has 5-second delay left side, 5-second delay right side. Sir, what is this 5-second delay? That means whenever a bit comes onto the line, then within 5 seconds of time it will go away from the medium, from leftmost, and this will travel this side within 5 seconds. After 5 seconds it is going away. Now what I want to say is, if such computer C sends one bit, what is going to happen? I will tell you. Within 5 seconds of time, everyone will know that channel is busy. Why? See, first second, second second, third second, fourth second, fifth second. By fifth second, so 0 occupied everything. Sir, but we have a question. What is that? At first second 0 is here, but second 0 is here. Now our question, at second 0 is not here, right? Yes. What if at second if 0 is here, but still two computers A comma B will think that channel is free, correct? But do you think that your computer is going to send only one bit? No, right? Then the other bits which are friends of C, usually we send thousands of bits, correct? Now example, first bit whenever come onto the line, then it will be only 1, but after 1 second they will become 2, correct? Now you see, the second bit will come, then third bit, fourth bit, fifth bit. Now what I want to say is, see, when first bit comes here, then second bit, third bit, fourth bit will follow. Now what I want to say is, after 5 seconds 0 will reach here, correct? That means signal, it is easy for us to understand in the terms of signals. If the first signal comes here, the second bit signal will be here, third bit here, fourth bit here, fifth bit here. Understand? Now this side also, first bit, fifth bit, fourth bit, third bit, second bit, 0th bit. That means when first bit comes here, then all the remaining bits will occupy the channel. That is what I want to say. Understand? That's why one more thing, don't send. Otherwise, generally computers won't send only one bit. Whenever you send one bit, it will be very difficult to identify the collisions and all, correct? But when thousands of bits if you send, then definitely we can detect the errors. Okay, now we'll see how this collision detection is going to take place. I am just giving you the idea how signals are going to be propagated, because here you get lot of questions, how signals go and how channels, how your computers are going to sense the channel, everything. Okay, that's why I'm spending a lot of time. If you understand before I teach, then you simply skip this part. Okay, so here I am teaching all these things very slowly, so that the people who don't understand, who have lot of questions about how signals propagate, how systems are going to sense everything, so for that I am giving you this idea. Okay, finally, vulnerable time is nothing but exactly propagation delay. That means when a signal starts coming, within propagation delay time, everyone will know about the channel. Understand? Now we'll see how to implement collision detection. Okay, so to understand collision detection procedure, first of all you see the problem. Example, so A is sensing the channel, but A is generally, already I told you that in this model, entire model, a station senses the channel only while it has data. That means example A doesn't have data, so it is going to keep quiet, it won't sense. And example, let's say there is a collision in the channel, but still it won't understand, otherwise it won't need it, correct? So only the station which wants to send the data, that station only is going to sense the channel. so that, so what happens, we can we can save lot of energy. Otherwise, if a station always sends, then unnecessarily it consumes lot of its energy. That's why, to not to lose the energy, any station senses the channel only if it has the data. Remember it. Now at this moment, let's say example A has data, some bits, okay, 0 1 0 1, whatever it is, a small packet or frame. Now this frame station A wants to send. Before that, it sends as a channel. At this moment, let's say your channel is free, then it is going to send. Once it sends, what happened? First of all, it send 0, after that it send 1, after that it send 0, after that it send 1, correct? So 0 will start going, after that 1 0 1. See the situation. What is our goal finally? Capability of detection, right? How to detect whether this 010 is going to successfully reach the destination or not, correct? Now for that, what we are going to do is, we are going to check the channel. That means we send the data, at the same time we send the, I can say we sense the signals also, resultant signal. See, there will be two things here for collision detection. What we do is, we send the data, at the same time we sense also. So what happens, we will see. Example, at the same time B is also sending the data. What happens, we'll see. Now A is sending 0 and B is sending 1. Let's show with the signals, okay. Now B signal is coming like this, A signals are going like this. After some time, what happens? Assume that, let's say, still you are sending. That's why you sense it, correct? While sending, if you sense, then definitely after some time, so this B signals will come, and by that time, if you can sense, then you will see the voltage difference, otherwise energy level. So you will see the energy level in the channel which is higher than general, right? That means you see energy level 10, but actual energy level should be 0 or 5. 0, no signal, 5, only one signal, but now signal, energy level 10. So this A will understand that energy level is 10. That means I am sending the data now, but some others also sending, that's why energy level is 10. Immediately it will understand the collision. So that is the way collision detection is going to take place, but you should be very careful. First of all, I will tell you the complete procedure, how this collision detection is going to work. Every station, whenever they want to send the data, they will sense it first. This is of course CSMA, right? So using the CSMA, we sense it. Now once you see that station is, your channel is empty or free, then start sending. But while sending the data, even at that time also you sense the channel, okay. Now example, just send bit 0, but we are sensing also at that time. So you will sense 0 only, then you see energy level 5. Then after that you send 1, then again you see signal energy level 5, then again you send 0, then signal energy level will be 5. In that way, keep on sending your all the bits and keep on sensing the channel, okay. So that's why in CSMA CD we say that we are going to send the data and sense the channel. Now really, if others also send the data, eventually their data will come like this, and you are also sending your data, then energy level will be different. Then you will detect it. That is called collision detection. Now there is a danger. If you don't properly implement, what is going to happen, I will tell you. Now consider this situation where you have only 4 bits, okay. Then station A wants to send this 0101. Initially your station is ideal, right? So immediately your station A is going to send 0, after that 1, after that 0, after that 1. So first bit 0 will come onto the line. Then after that, so this 0 will move to the next position, correct? So we will see this entire thing over the period of time. Let's assume that t is 0 first. After that we will see the case when t equal to 1, then t equal to 2, t equal to 3, in that way. So when t equal to 0, nothing, so station A is ready. When t equal to 1, first bit, let's say, came to the line. Now when t equal to 2, then 0 will move to little bit further, then new bit will come, right? So in that way propagation will take place. Then when t equal to 3, so you will see here 0, then 1, then 0. Then when t equal to 4, then you will see this 0 here, this 1 here, this 0 here, this 1 here, in that way. So slowly these 1010 over the period of time when t equal to 4, they will be moved. Then when t equal to 10, assume that let's say your 4 bits, let's see like a signal now. So this is let's say 0, this may be 1. Okay, so first bit is, we know that 0, correct? So last bit is 1, so it will be like this, 1, then 0, 1, 0 will come here. By that time, so this first bit of D is also coming onto the line, that will touch this 0. Okay, now what I want to say is, so far A was detecting the line, correct? That means it was sensing the line. But after sending all these 4 bits, by that time whenever t equal to 10, then A already sent entire data into the line. Now station A won't sense, because according to our CSMA CD, please recall, in CSMA CD, what we do, any station whenever it has a data, then only it will sense it, correct? Now already A's data is all completely on the line, then station A will shut down that process. Then after this point of time, so detection is, collision is occurring. Now your station A is not able to detect. Really in CSMA CD procedure, whenever a sender sends data, then he should be able to understand whether his data is successfully transmitted or not. Then only we say that is CSMA CD procedure. Here we are going to design a protocol where sender knows, at least sender knows that there is a collision. For that you tell me, what is the problem? Why A was not able to understand this one? Because by that time he was not sensing the cable. Why he was not sensing the cable? Because by that time he doesn't have data. We know that whenever we have data, then only we sense it, correct? That's why you should have enough data so that whatever may be the collision case, you should be able to detect. So what I want to say is, if this A has little bit more data, he could have detected it. How? Example, let's say he has very large size of message, then what is going to happen, you see? So this garbled message slowly will come like this, correct? Over the period of time. Still assume that let's say A is sending, then whenever that garbled message comes here, then this bit of this sender will collide with it. Now sender is going to detect the increase in the voltage level, otherwise energy level. So he will detect. What I want to say finally is, so your sender, otherwise any sender, has to send a message so that in the worst case also he should be able to detect. For that he should send longer message. But what could be the minimum size message he should send, so that in any case he will detect the error? We will see. So in the worst case, so your signal starts here. Try to understand. This is the longest duration where after this you are going to get the collision. Okay. Why I am only taking case for A, I will tell you. Because see, this is the longest duration, I can say, where a signal still has no collision. Okay, see now, still there is no collision. That means what? It doesn't mean that there is no collision. There might be a collision, right? So what can happen here at this point of time? So this signal starts coming, because of that, see now there is a collision, but still A should not stop its sending. What is the reason? Now it cannot detect the collision by that time. So now this signal will slowly come. Now see here, now there is a collision, correct? That means already collision has started, but it will reach A only after one more propagation delay. So what I want to say is, in the worst case, so your signal starts here, it will go up to this point, which is nothing but end. That means propagation delay. After propagation delay, so you get collision, but that collision will be reached to you after one more propagation delay. So what I want to say is, after 2 into propagation delay only you can recognize that there is a collision. Then by that time, if you are not sensing your cable, then you can't detect. So that's why in CSMA CD procedure, so any system is going to send a message which should be enough long, so that it will the duration of that message, otherwise the transmission time of that message should be at least 2 into propagation delay. Very simple. We'll see one numerical problem. Example, this is, let's say, a small case, 1 kilobyte per second. Okay, 1 kbps. This is the bandwidth of the channel, and propagation delay is, let's say, very small we take. Okay, so 50 meters. Now assume that light capacity, otherwise signal speed in this medium is 2 into 10 power 8 meters per second. Now my question is, what should be the message size? At least, I mean, minimum size I'm asking. You can have very big message, that's okay. But what should be minimum size so that any station can detect? Here what I want to say is, if you covered only case for A, right, then you just observe for B. Then automatically that will be satisfied by B. Example, when you can, I mean, any system has 2 into propagation delay duration message. That means whose transmission time is 2 into propagation delay, then what is going to have, you see, example B starts such message. It is, what is the duration of that message? That means its transmission time is 2 into propagation delay. Then, so example, that message starts here, then it will go like this, correct? So if collision occurs, then before 2 into propagation time, propagation delay time, so definitely B is going to get the signal back, isn't it? So here from A also, right? If A sends same signal from here, then very quickly B will get the collision. What I want to say finally is, so only if you calculate case for A, then it is like calculating, otherwise covering B, C, D, everything, correct? So that's why I said maximum, duration should be 2 into propagation delay. Now we are going to put a condition on this CSMA CD protocol, that is, in this system, whatever the systems we have in this model, so every system should send frames with at least some minimum size. Okay, so what is the minimum size frame? So this system should send we will see that. For that, assume that, let's say, bandwidth of every system is 1 kbps. Otherwise, just assume that this channel bandwidth is 1 kbps. Okay, where B is nothing but byte. Speed is 2 into 10 power 8, and propagation delay is, let's say, it's not propagation delay, it's length of the cable, which is 50 meters. Okay, length of the cable is 50 meters. Now we will see the propagation delay. We know the formula for propagation delay. What is that? So simply distance by speed, correct? 50 meters is your cable and signal speed is 2 into 10 to the power of 8 meters per second. Generally I never apply the formula. I usually do the things like this. What is the meaning of this one? It says that signal speed is 2 into 10 power 8 meters per 1 second. That means such signal can travel 2 into 10 power 8 meters per second. If you have 50-meter cable, then how long it will take for that signal to travel? It's direct proportionate. If it can go 2 into 10 power 8 meters in second, then for 50 meters definitely less, correct? What is less in these two? 50. That's why you write 50 on top, 2 into 10 power 8 on downside, and multiply with 1. So this is the formula for proportionate, right? So 50 by 2 into 10 power 8, if you cancel it, it will be 25 into 10 power 8. So I can say this one as 25 into 10 power minus 8, isn't it? Then I can write 0.25 into 100. 100 into 10 power minus 8 is 10 power minus 6. So it is actually 0.25 microsecond. Very short, correct? Now your message size should be, exactly, otherwise at least 2 into propagation delay. Let's do 2 into propagation delay. 2 into propagation delay is 0.25 into 2. 0.5, correct? 0.5 microseconds. So your message, whatever the frame you are going to take, its transmission time should be 0.5 microsecond or more than that. So we know the formula for transmission time. What is that? Message size. But we don't know what is the message size. If I take message size x, but it should have 0.5 microsecond delay. For that, what is the bandwidth? 1 kbps, right? What we do is, because 1 kbps is very small bandwidth, let's change it to 1 mbps. Okay, generally, so kb is very slow, right? So if you have large bandwidth, then only generally it will be good. So I am taking 1 mbps. So if I take 1 mbps, what happens? It will be 10 to the power of 6 bytes. Byte is nothing but 8 bits, correct? Per second. So second will go up. Should be greater than or equal to 2 into propagation delay. What is propagation delay? So this, of course, we know the product of 2 into propagation delay, right? That is 0.5 microsecond. So x greater than or equal to second will be cancelled. You get 8 into 0.5 into 10 to the power of 6 into micro. Micro is 10 power minus 6, right? So minus 6 and plus 6 will be cancelled. Then you get x greater than or equal to 8 into 0.5, which is nothing but 4. So since you have very small cable, 50 meters, So there is no problem. Quickly, your signal goes to this point and will come back. That's why you got frame size as greater than or equal to 4. So this value says that whenever you have 4 bits, that is sufficient, we can detect the error. Why, sir? The reason, we have taken this distance as only 50 meters. So light actually goes very fast. So 2 into 10 power 8 meters per second. So to cover 50 meters, it takes only of course only 0.5 microsecond. That's why, so you are able to detect the collision easily. But what if I change this 50 meters to something around, let's say 10 kilometers, or let's say 10 kilometers, then everything will be changed and you get different answer, and maybe further you get a little bit big answer like 100 bytes something. Okay, so what I want to say is this cable's length and your bandwidth are going to decide what should be the minimum frame size in CSMA CD. In one line, I would like to tell one important point here, that is, whenever you want to apply CSMA CD procedure or protocol, so there should be a minimum frame size restriction we have to impose on the stations. Otherwise, so that kind of corner station like A, that cannot detect the collision sometimes. Understand?